Hello students, today we are going to start polynomial quadratic equation. So before going to quadratic, we will see some facts about polynomial. A polynomial, as we all know, that a polynomial of degree n is of the type an x to the power n plus an minus 1 x to the power n minus 1 plus 8. This is a polynomial function and px is equal to 0 is a polynomial equation. If we say this is equal to 0, then it is a polynomial equation. Px is equal to polynomial, then px is equal to this 0 is an equation. So this is a polynomial of degree n if an is not equal to 0. If an is not equal to 0, then it is called a polynomial of degree n, and p equal to 0 will be a polynomial of degree polynomial equation of degree n. So this equation has exactly n roots. A polynomial of degree n, polynomial equation of degree n has exactly n roots except the 0 polynomial. Except the polynomial px या fx is equal to 0. Px equal to 0, if this is a polynomial, then it has infinite zeros. This polynomial has n zeros. Either we can say px equal to 0 has n roots, but the polynomial px equal to 0, this is its degree is not defined because px is equal to 0, the coefficient of all the terms, all the coefficients are 0. Huh? So except the polynomial px equal to 0 which has infinite zeros. Every value of x satisfies this equation. So we will now we will see about quadratic equation. Quadratic equation ax square plus bx plus c equal to 0 is called a quadratic equation if a is not equal to 0. A should not be equal to 0 for it to be a quadratic equation, and it has exactly two roots. These two roots can be real, can be imaginary, either equal, that we will see later in nature of roots. But a quadratic equation where leading coefficient is non-zero, it has exactly two roots. So we will see different conditions where the coefficients a, b, c can take either 0 values or not. Let's say let's consider this equation. So we are taking different cases. When a is not equal to 0, then this is a quadratic equation which has two roots. If a is equal to 0 and b is not equal to 0, for a equal to 0 and b is non-zero, this equation becomes a linear one. As we can see, the leading coefficient is 0. Now the leading coefficient becomes the coefficient of x, which is b. So this will be a linear equation and it will have one root only. It will have one root only. If a and b both are 0 and c is non-zero, then a and b both are 0. So this will become 0, this will become 0. C is non-zero, C is equal to 0. Non-zero equal to 0, this cannot be possible. So it is a contradiction. So it will have 0 roots, no roots at all. Okay, non-zero equal to 0 is not possible. Now we are taking another case when a is equal to b is equal to c is equal to 0. In this situation, a is 0, b is 0, c is 0, irrespective of what the value x can take, this equation becomes 0 is equal to 0. So every value of x will satisfy this equation. This type of equation, which is satisfied by all the values of the variable, is called an identity. So the equation becomes identity when it is true for all the values of the variable. In this case, it will have infinite roots. It will have infinite roots. See, this is an identity, an equation, we can say an equation, an expression which is true for all the values of the variable. Let's say sin square theta plus cos square theta is equal to 1. We do not say that find theta if sin square theta plus cos square theta equal to 1. It is an identity. It is true for all the values of theta. It is true for all the values of the variable theta. That's why, see, if I am saying x square minus 4x plus 4 is equal to x minus 2 whole square. So this is an identity. This will be true for all the values of x. It is just the formula of x minus 2 whole square, a minus b whole square, it is written. So this is true for all the values of the x. As we will take the expressions there at the same side, the coefficient of x square becomes 0, all the terms will cancel out, coefficient of x square, coefficient of x and constant, all will become 0. So in general, we say that if a quadratic expression or a cubic expression, we can say that if a quadratic expression is satisfied by more than 2 values, then it will be an identity. A cubic expression is satisfied by more than 3 values, then it will become an identity. A polynomial equation becomes an identity if all the coefficients becomes 0, so it will be satisfied by infinite values of x. Okay, so we will take an example of identity. Is equal to 0 is satisfied by more than 2 values of x, then find the value of a. If this equation is satisfied by more than 2 values of x. So see, we are given that this equation is satisfied by more than 2 values of x. So it is a quadratic in x. So quadratic in x will have exactly 2 roots. Now it is saying that it is satisfied by more than 2 values, so it will be an identity, and condition for identity is the coefficients of x square, x and the constant coefficient all are 0. So we can say this is possible only when it is an identity, and condition for identity is the coefficient of x square is equal to coefficient of x is equal to constant, all are 0. So a square minus a minus 2 is equal to 0, and a square minus 1 is equal to 0, and a square plus 4a plus 3 is equal to 0. Now we have to find the value of a at which all the terms are 0. That's why I have written AND here. So from this, the value of a is either 2 or minus 1, either 1 or minus 1, either minus 1 or minus 3. So we are not here to take all the values of a which are satisfying this. We have to take the value of a which satisfy all the three conditions. So the common value is -1. So the answer of this question will be, for a equal to -1, all the terms will become 0 and this equation will become an identity which is satisfied by infinite values of x. Any value of x you can put, you will get the result 0 is equal to 0. Let's see one more problem. Show that the equation is equal to 1 is an identity in x. See, you can pause the recording and try to solve this problem. So I am starting, I am solving this. So we have to prove that this equation is an identity in x. As we can clearly see that this is a quadratic equation. If we take LCM, and the equation will be in the form of ax square plus bx plus c. So if we want to prove that it is an identity, then the coefficient of x square must be 0, coefficient of x must be 0 and constant term must be 0. This is one of the ways to solve this problem, which will become quite lengthy. So we will have to take the LCM, a minus b, b minus c, c minus a. Then we will collect the terms coefficient of x square, coefficient of x, constant -1. We will simplify this. Coefficient of x square will be 0, coefficient of x will be 0, coefficient constant term will be 0. So we will be able to prove that it is an identity. Let's go for a smaller method, quicker method to solve this question just by observation. Just by observation, how can we approach? See, in this question, x minus a, x minus b, and the denominator is c minus a, c minus b. X minus b, x minus c, denominator is a minus b, a minus c. X minus c, x minus a, denominator is b minus c, b minus a. So we can observe that if x is equal to a, then if I am putting x equal to a in the equation, then 0 plus 1 plus 0 is equal to 1. This equation is satisfied by the value of x is equal to a. So x equal to a is the root of this equation. Similarly, if x is equal to b, then 0 plus 1, the equation is satisfied by x equal to b. So x equal to b is the root of this equation. Similarly, x equal to c also satisfies. So x equal to c is also the root of this equation. Now there are three values of x which are all distinct. How can we say that we are distinct? In the question it is not given, but I can see that in the question the denominator is c minus a, c minus b, a minus b, a minus c, and b minus c, b minus a. So the question itself says a is not equal to b, b is not equal to c, and a is not equal to c. It means that all the three values are a, b, c are distinct. Now we have come out to the point that three distinct values of x satisfies this quadratic expression. this is an quadratic expression, this is a quadratic expression, and three different values of x are satisfying this equation, hence this is an identity. Three distinct values are satisfying the equation, hence we can say that it is an identity. It is sufficient to show that a quadratic equation is satisfied by three distinct values of x, then it will be an identity. Okay. So till now we have covered the concept that what is the difference between an equation and an identity. Specifically we have seen the difference between quadratic equation and identity. Those two problems were type of a quadratic equation which was satisfied by more than two values, or say let's say that was an identity. Cubic also we can say that if the equation ax cube plus bx square plus cx plus d equal to 0, if the equation is satisfied by more than three values, then this will be an identity. Okay. So I hope the concept of identity is clear to you all. Now let's move forward to the roots of quadratic equation. So we are considering the quadratic equation ax square plus bx plus c is equal to 0, and if it is a quadratic equation, we are saying that it is a quadratic equation, so a will not be equal to 0. First we will find the roots of this quadratic equation. So what I will do, I will divide the equation by a, and I will use the concept of making perfect square. So the coefficient of x is b by a. So what I will do, I will add and subtract the square of half of the coefficient of x. So this expression will become x plus b by 2 a whole square. The remaining term will be now I am taking square root on both sides. This is plus minus root b square minus 4ac upon 2a. So x is equal to minus b plus minus upon 2. Okay, so this is called the quadratic formula. We have used it, we have seen it so many times. Quadratic formula of finding the roots of quadratic equation minus b plus minus root b square minus 4ac upon 2a. Either we can apply this formula or we can use the factorization method to find the roots of quadratic equation. Now let's say these roots are alpha and beta. We have found the two roots of quadratic equation. Let's say these roots are alpha and beta. Now what I will do, I will find the relation between roots and coefficients. So sum of roots which is alpha plus beta is minus b plus root b square minus 4ac upon 2a. Which is minus b by a. So sum of root is minus b by a minus coefficient of x upon coefficient of x square. Similarly, we will find the product of roots. Product of roots so this will become b square minus c by a. So product of roots alpha beta is c by a, which is constant upon coefficient of x square. So this we will have to remember. For the quadratic equation ax square plus bx plus c equal to 0, sum of roots is minus b by a, product of roots is c by a. And for the future calculations, we can also remember the difference of roots. Difference of roots, we will use the formula alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. Sum of roots is minus b by a, product of roots is c by a, b square minus 4ac upon a square. So the difference of root will be magnitude modulus of alpha minus beta b square minus 4ac upon mod a. See, we are taking the difference, so mod a will give the absolute value alpha minus beta, whether alpha will be greater than beta or beta will be greater than alpha. We are interested in the difference of roots, so I have applied the modulus sign. See, now so many expressions can be find out using sum and product. Alpha square plus beta square, alpha cube plus beta cube, alpha cube minus beta 4, alpha power 4 plus beta power 4. These are the values which we can found using the sum of roots and product of roots. See, ax square plus bx plus c equal to 0, if it has root alpha and beta, then sum of root and product of roots we can write. Another way of writing this quadratic equation is, if ax square plus bx plus c equal to 0 has roots alpha and beta, from the factor theorem which we have studied in earlier classes, if x equal to alpha is the root of this equation, then by putting x equal to alpha this expression will become 0. So we can say that by factor theorem x minus alpha will be a factor of this expression, this polynomial. So x minus alpha is a factor. Similarly, x minus beta is also a factor. The quadratic expression will have exactly two factors. So we are putting equal sign. So the coefficient, leading coefficient must be equal. So we can also write this quadratic expression ax square plus bx plus c is a times x minus alpha x minus beta, provided the roots of the equation are alpha and beta. You can check the right hand side. If we multiply this is sum of roots minus b by a, this is product of roots c by a, so the expression will become ax square plus bx plus c. So this expression is quite helpful in many problems, that we can find the solutions of some problems by writing ax square plus bx plus c equal to as a times x minus alpha into x minus beta. Okay. We can also write the equation when the roots are given. Roots of the equation are alpha and beta. Then the quadratic equation is see, this is sum of roots, this is product of roots. X square minus sum of roots into x plus product of roots is equal to 0. X square minus alpha plus beta x plus alpha beta is equal to 0. So if we are given the roots, then we can write the equation. If roots are alpha beta, then the equation will be x square minus sum into x plus product equal to 0. Another way of writing the equation is using the transformation of roots. We will study later today itself. First we will do some problems on the relation between roots and coefficients. The least prime integral value of 2a such that the roots alpha beta of the equation two x square plus 6x plus a equal to 0 satisfies okay. So a quadratic equation is given and its roots alpha and beta satisfies this expression alpha by beta plus beta by alpha is less than 2. Now we have to find the least prime integral value of a to a such that the equation root satisfies this. Okay, so the parameter a is to be find out, and from that we can say that value of 2a is this and the least prime value of 2a is this. So you can pause and try to solve. I am solving it right now. Alpha by beta plus beta by alpha. So what we will do, we will try to write this expression as sum and roots and product of roots. So alpha beta, alpha square plus beta square minus 2 less than 0. We can write this as, now alpha square plus beta square, we can use alpha plus beta whole square minus 2 alpha beta upon alpha beta. See, now this expression is in the form of sum of roots and product of roots. Alpha plus beta, what will be the value of alpha plus beta? The roots of this equation are alpha and beta. The sum of root will be minus b by a minus coefficient of x upon coefficient of x square. So this will become minus 3 product of roots constant upon coefficient of x square. This we can write alpha beta is a by 2, alpha plus beta is minus 3. Put these values in this inequality. 9 minus a upon alpha beta is a by 2 minus 2 is less than 0. So 18 minus 2a upon a minus 2 is less than 0. 18 minus 2a minus 2a upon a less than 0. Take common 2. 9 minus 2a upon a is less than 0. Now we will solve this inequality using Webby curve method. Minus plus minus. For less than 0, the value of a will be minus infinity to 0 union 9 by 2 to infinity. We are only interested in prime values, so prime values are positive. So a is greater than 9 by 2 only. 2a is greater than 9. So we have found that 2a should be greater than 9. Now least prime integral value will be prime number greater than 9. Least prime number greater than 9 is 11. So least prime integral value of 2a is 11. Answer of this problem is 11. Got it? Let's go for another problem. If both roots of are prime numbers, then find all the possible values of C. Try to solve this problem. In this question, we are given that both the roots are prime numbers and we have to find the values of C, all the possible values of C. See, the equation is x square minus 32x plus c. Let's say the roots are alpha and beta. So what we can write, we are given that alpha and beta are prime numbers. See, what we can write, the sum of roots 32 and the product of root is c. We are to find c. So we will see the equation alpha plus beta equal to 32. Now we are given that alpha and beta both are prime numbers. So I can clearly say that both alpha and beta are less than 32, as all the prime numbers are positive integers. Okay, so alpha and beta both should be less than 32. So our problem is actually half solved. We only have to deal with the prime numbers less than 32, which satisfies this equation. So let's start. 32, the smallest prime number less than 32 is 31. If I take one of the values as 31, the other will become 1, which is not a prime number. So 31 is rejected. Next, after 31, the least prime number is 29. So if I take one of the value as 29, then other will become 3. Both are prime numbers. This is one of the value of C. What will C will come? 3 into 29. One of the values of C is 87. We will move forward. Now the prime number less than 29 is 28, 27, 26, 25, 24, 23. If we take 23, then beta will become 9, which is not a prime number. So 23, 22, 21, 19. If I take this 19, then this will become 13. Both are prime numbers. So another roots I have come out, 19 and 13. C will be 19 into 13. 7, 247. One of the values of C is 247. Now move forward. 19, if I take this 17, this will become 15, not a prime number. All cases are done. So we have solved this problem. We are getting 2 values of C. So find all the possible values of C. So C is equal to either 87 or 247. Okay. So using the sum of roots and product of roots, we have found the value of C, and using the sum of roots and the question, in the question it was given that all the roots are prime numbers. Okay. Let's move forward to another problem. So this problem is saying that the sum and product both are less than 1. The sum of the roots of this equation and the product of roots of this equation are both less than 1, and we have to find the parameter lambda. So sum of roots will be in terms of lambda, product of roots will be in terms of lambda, and we have to solve two inequalities, alpha plus beta less than 1 and alpha beta less than 1. So you must have tried this problem. Let's solve. Sum of roots we can write minus b by a lambda square minus 5 lambda plus 5. It is given less than 1. So this is quite a simpler inequality. The value of lambda will be 1 to 4. Now the product of roots. Product of roots is c by a. This is also less than 1. The factors will be 2 lambda minus 5 lambda plus 1 lambda minus 1 to 5 by 2. So we have to find the lambda for which both are less than 1. So we will have to take the intersection of these two inequality. 1 intersection 2, we can either write it directly or use the number line. Minus 1 1 5 by 2 4. Equation first, according to equation first, lambda is from 1 to 4. According to equation 2, lambda is from minus 1 to 5 by 2. The intersection will be 1 to 5 by 2. So how many integral values, if we are to ask the number of integral values for which this happens, that will be only 1, which is lambda is equal to 2. Okay. Next question is find the roots of the equation See, in this equation we are here to find the roots of this equation. So either we can use the quadratic formula which we have derived earlier, minus b plus minus root b square minus 4ac upon 2a. From that we will be able to get the two values of x which satisfies this equation. This is the problem. Obviously we are not going to solve that equation. So what we will do this problem by observing the equation, and this observation you must remember, either this or this type of equation. What does it say? What does it say? That sum of all the coefficients is 0. You can observe, you can check if the sum of all the observations in an equation is 0, in any equation, either be it quadratic or cubic or 4 degree or biquadratic. If the sum of all the coefficients in an equation is 0, then we can surely say that x equal to 1 satisfies that equation. Sum of all the coefficient, how will you get sum of all the coefficient? If you put x equal to 1 in that equation. By putting x equal to 1, the expression becomes alpha minus beta plus beta minus gamma plus gamma minus alpha, which will be 0. So by observation we can say that x equal to 1 is the root of this equation. As x equal to 1 satisfies this equation, alpha minus beta plus beta minus gamma plus gamma minus delta is equal to 0. As x equal to 1 satisfies this equation, so we can say that x equal to 1 is the root of this equation. Now x equal to 1 is the one of the root. Now the second root we can find using the sum of roots or product of roots. Product of roots is quite easy. Let other root is a. So the product of roots a into 1, one of the root is 1, other root is a, is equal to gamma minus alpha upon alpha minus beta. So other root is gamma minus alpha upon alpha minus beta. So the quadratic equation has two roots, 1 and gamma minus alpha upon alpha minus beta. This you can also find by using sum of the roots. By sum of the roots, one root is 1, other root is a. So 1 plus a will be minus beta minus gamma upon alpha minus beta. You can get the same result. Okay. Let's move on to the next problem. Let ABC be real numbers. If alpha beta are the roots of then find the roots of in terms of alpha and beta. ABC are real numbers, A non-zero. Roots of the equation are alpha and beta, then find the roots of this equation in terms of alpha and beta. See, now quadratic formula. if we want to use quadratic formula, this will be a pretty difficult task, pretty lengthy task. Alpha beta minus b plus minus root b square minus 4ac upon 2, and the roots of this equation will be again minus b, which is abc, plus minus root b square minus 4ac, and we have to consider that expression. We have to simplify that expression in terms of alpha and beta, because we have to find the roots in terms of alpha and beta. Okay, so what we will do, we will try to express this equation in terms of ABC, sum of roots and product of roots. See, ax square plus bx plus c equal to 0 has roots alpha and beta. Alpha plus beta is minus b by a, alpha beta is c by a. So one way is to solve this problem simply is we change this equation in such a way that these type of expression we can see, minus b by a, c by a. So we will put minus b by a as alpha plus beta and c by a as alpha beta. Let's try to convert this equation in these two terms. So we can see these type of expression in the equation. What we can do, b by a, c by a, so c cube we are seeing c cube a cube, divide this equation by a cube. So bc by a square x plus c cube by a cube. I think the problem is half done. B by a, c by a we can see, c cube by a cube we can see. So I can write this equation as minus b by a and c by a. The expression remains unchanged, x square plus bc x by a square plus c by a whole cube is equal to 0. See, now I can write minus b by a as alpha beta, c by a as alpha beta, minus b by a as alpha beta, and this is alpha beta whole cube. So the expression, the equation has become x square minus this into x plus alpha beta whole cube. Just one more thing needs to be done and the question is solved. I am writing the equation again. So we have arrived to this expression. Now what I am changing, x square minus by multiplying this alpha square beta plus alpha beta square x and alpha beta cube. See, now I think everyone is getting alpha beta cube. I can write alpha square beta into alpha beta square. So what this is written, x square minus sum of the roots into x plus product of roots is equal to 0. We have seen, we have told you earlier that if the roots are given, then we can write the equation as this, x square minus sum of the roots into x plus product of root, and we compare these two. We can say that roots of this equation are alpha square beta and alpha beta square. This is quite a nice problem, good problem, where we are using the given equation. We are using the given equation's roots in to find the equation of another, roots of another equation in terms of roots of the previous equation. So hopefully you are getting this question. This is quite a good problem. First we divided this equation by a cube and the expression becomes in terms of minus b by a and c by a, which is the sum of roots and product of roots of the previous equation. Now simplifying this, manipulating this, we got the final answer that the roots of this equation are alpha square beta and alpha beta square. Let's move forward to the next problem. Let fx is equal to a and b are non-zero real numbers. A plus b is not equal to 0 if alpha beta are roots of fx equal to 0, then find the value of this expression. Okay, a is not equal to 0, b is not equal, a and b are non-zero real number. See, a plus b is also not equal to 0 because we have to find this expression. 1 upon alpha square minus a alpha. So, see, the equation x square minus ax plus 1 minus b, this equation has roots alpha and beta, and what we have to find, we can see that in this expression we have to find the value of alpha square minus alpha, beta square minus a beta. This equation is x square minus ax minus a minus b equal to 0. If alpha satisfies this equation, so we will, if we put alpha in this equation, we will get alpha square minus a alpha, and if we put beta in that equation, what we will get beta square minus a beta. So it will become a quite simpler problem if we go through the equation. See, one way to deal the problem was exclude minus 2 upon a plus b. We could take LCM. Of this expression and try to change this expression in terms of sum of roots and product of roots, like this. And this was also an approach. Alpha square plus beta square, we can found alpha plus beta whole square minus 2 alpha beta. Alpha into alpha plus beta, a into alpha plus beta, we can find sum of root, product of root, numerator is sorted. Now if we multiply this, alpha beta square minus a alpha beta, alpha plus beta plus a square alpha beta, this is the denominator. Product of roots, sum of root, product of roots, product of roots. So numerator and denominator both are sorted, but this is one of the way to solve, but we are not going to solve by this approach. We are thinking that in this expression alpha square minus a alpha is given and the equation is x square minus ax, beta square minus a beta, x square minus ax. We know that alpha and beta are the roots of this equation. So if we satisfy this equation by alpha and beta, what we will get, alpha square minus a alpha minus a plus b equal to 0. From that, alpha square minus a alpha is a plus b. If we put beta, we will get similarly beta square minus a beta is a plus b. The question is done in two simple steps. Alpha square minus a alpha. Now we have to find the value of this expression. Alpha square minus a alpha is a plus b plus a plus b minus 2 upon a plus b. This will become 0. See, so what matters is how we look at the problem. If we could have observed that this expression can simply be find out using this, then we would not have to do this type of calculation. Similar problem is if alpha beta are the roots of ax square plus bx plus c equal to 0, and we have to find the value of 1 upon a alpha plus b square 1 upon a beta plus b square. See, using the relation between roots and coefficients, one way to deal with this problem is we take LCM. Simplify this, convert all the expressions in terms of sum of roots and product of roots, that is alpha plus beta and alpha beta. Okay, then put alpha plus beta minus b by a, alpha beta c by a. But this problem can easily be done using the same way we have done the previous problem. We are seeing an expression containing a alpha plus b and a beta plus b. So if ax square plus bx plus c equal to 0 has roots alpha and beta, then a alpha square plus b alpha plus c 0. So a alpha plus b becomes minus c by alpha. Similarly, a beta plus b will become minus c by beta. Yes or no? Now, to find this expression, simply put the value of a alpha plus b and a beta plus b. So 1 upon c square alpha square plus beta square, which is quite simpler what we were doing earlier. Alpha plus beta whole square minus 2 alpha beta. So b square by a square minus 2c by a, b square minus 2ac upon a square c square. This is the expression you are looking for. So in today's lecture, what we have learned, this was the first lecture of quadratic equation. We have learned what is a quadratic polynomial, what is a quadratic equation, how its roots are related to its coefficients, and earlier that we have seen the difference between equation and identity, and we have done some problems of relation between roots and coefficients. We have also seen that roots are given that equation. How can we find the equation, quadratic equation? And another way of writing a quadratic expression if its roots are given. See, if roots of quadratic equation ax square plus bx plus c equal to 0 are alpha beta, then we have used this in the questions that sometimes if we put alpha and beta in the equation, a alpha square plus b alpha plus c and a beta square plus b beta plus c equal to 0, then the question is getting simpler. According to the question, we do this. And if roots are alpha beta, then we can write ax square plus bx plus c as a times x minus alpha into x minus beta. And if roots alpha beta are given, then the equation is x square minus sum of the roots into x plus product of roots is equal to 0. So let's start. But before starting the next thing, we would like to take some questions. If one root of the equation 4x square plus 2x minus 1 equal to 0 is alpha, then other root is, and we have been given 4 options. Okay, so we can do this problem. As we can see, one root is given as alpha and another root is also given in terms of alpha. Okay, so the question is not that simple, that if we can assume one root is alpha, other root is beta, sum of root is minus 2 by 4, that is minus 1 by 2. So minus 1 by 2 minus alpha, the other root must be 1 minus 1 by 2 minus beta, but it is not given in any of the options. Another way, the product of roots is minus 1 by 4, so beta minus 1 by 4 alpha. This also is not given in any of the options. So we can see that in each of the option, the term alpha cube is there, 4 alpha cube minus 3 alpha, 3 alpha minus 4 alpha cube, and so on. So let us check first option, 4 alpha cube minus 3 alpha. See, if alpha is root of this equation, then we can say that 4 alpha square plus 2 alpha minus 1 is equal to 0. So 4 alpha cube plus 2 alpha square minus alpha is equal to 0. 4 alpha cube is equal to alpha minus 2 alpha square. We can write 4 alpha cube as alpha minus 2 alpha square. So 4 alpha cube is equal to alpha minus 2 alpha square. Now this expression becomes minus 2 alpha square minus 2 alpha. Okay. See, another root is minus 1 by 2 minus alpha. So we want to convert this expression in terms of alpha only. So we can write alpha square as 1 minus 2 alpha by 4. So alpha square 1 minus 2 alpha by 4 minus 2 alpha. From this we get minus 1 by 2 minus alpha, which is our other root beta. So option A will be the right answer. Similarly, we can check B, C, D, and this will not be our answer. Our answer is A. This is a very good problem if we want to do it using only the concept of equation, quadratic equation. 4 alpha square is equal to 1 minus 2 alpha. We have reduced this alpha cube terms, this cubic expression. Using this expression, we have reduced this cubic expression into a linear one, and this linear one is our other root. We could also divide this cubic expression by this quadratic expression, 4 alpha square plus 2 alpha minus 1. Another way of dealing this problem is using trigonometry. If you have got the slightest idea of trigonometry, multiple angles, and the value of sine 18 degree, sine 54 degree, then you can do this problem using trigonometry. Let's have a look at that. 4 alpha square plus 2 alpha minus 1 is equal to 0, 4x square. So the root will be minus b plus minus b square minus 4ac upon 2a. So the root is minus 1 plus minus root 5 by 4. One root is root 5 minus 1 by 4, other root is root 5 plus 1 by 4 into minus 1. So this is sine 18 degree and this is sine 54 degree with a minus sign. So this is sine 3 theta. Sine 3 theta is 3 sine theta minus 4 sine cube theta. If theta is 18 degree, then 3 alpha minus 4 alpha. This will be our other root with a minus sign. So this will be 4 alpha cube minus 3 alpha. But this we have done using the concept of trigonometry. Okay, let's move to the next problem. If alpha beta are the roots of x square plus 3x plus 1 is equal to 0, then this time we have also we have given 4 options. 7 minus alpha 7 minus beta is equal to 2. 2 minus alpha 2 minus beta is equal to 10. Alpha square upon 3 alpha plus 1 minus 2 60. Okay, so now we want to check out of these options which one is correct or which one or more are correct. See, the first two options are very easy to check. If you remember that I have told you, if alpha and beta are the roots of x square plus 3x plus 1, then I can write this expression as x minus alpha x minus beta. This has become an identity now. I can put any value of x in this expression. So for a and b, if I put x is equal to 7, then this is 49 plus 21 plus 1 is equal to 7 minus alpha 7 minus beta. So option 1 is A is clearly incorrect. If I put x equal to 2 in this expression, 4 plus 6 plus 1 is equal to 2 minus alpha 2 minus beta. So this is 11, here it is given 10, B is also incorrect. Okay, so A and B, for A and B we have used this concept. Now for C and D, one way to deal with this is take LCM, convert every expression, convert all the numerator and denominator in terms of sum of roots and product of roots. Put alpha plus beta minus 3 alpha beta 1. Here we could also do that. Product, multiply this and put alpha plus beta is equal to minus 3 sum of roots and alpha beta 1. But we did this using this concept, which is quite simple. Now in C and D also we will use the given quadratic equation. See, here it is written 3 alpha plus 1 and 3 beta plus 1, and we have x square plus 3x plus 1. So if alpha and beta are the roots of this equation, then alpha square plus 3 alpha plus 1 will be equal to 0. So I can say 3 alpha plus 1 is equal to minus alpha square. Similarly 3 beta plus 1 is equal to minus beta square. So why not put these values in the option C itself? So in LHS of option C becomes alpha square upon 3 alpha plus 1, that is minus alpha square, plus beta square upon 3 beta plus 1, that is minus beta square. So this is quite easily done, that option C is correct answer, minus 2. Let's check option D also. Alpha upon 1 plus beta whole square. Alpha square upon 1 plus beta square upon 1 plus alpha. The equation given was x square plus 3x plus 1. So this is 1 plus beta square plus 2 beta, 1 plus alpha square plus 2 alpha. If alpha and beta are the roots of this equation, then 1 plus alpha square will be equal to minus 3 alpha, 1 plus beta square will be equal to minus 3 beta. So 1 plus beta square is minus 3 beta and 1 plus alpha square is minus 3 alpha. So this expression is quite easy to deal with respect to that expression. Now take LCM, this expression becomes alpha cube plus beta cube upon alpha plus beta whole cube minus 3 alpha plus beta upon alpha beta. Put the values sum of roots and product of roots, minus 3 upon 1. So this is 27 minus 9, 18 plus 18, 16. This is incorrect option. So our correct option is option C. Let's move forward to another beautiful problem. This is a question of IIT JEE 2006. If A, B are roots of x square minus 10cx minus 11d equal to 0 and C and D are roots of x square minus 10ax minus 11b equal to 0, then find the value of a plus b plus c plus d. Here it is given that a, b, c and d are distinct. They are distinct real numbers. Okay, this was asked in JEE, IIT JEE exam 2006. So how we can deal with this problem? See, this equation has roots a and b, and x square minus 10ax minus 11b has roots c and d. First of all, using the concepts of relation between roots and coefficients, we can write sum of roots and product of roots. A plus b is 10c, ab is minus 11d, c plus d is 10a, cd is minus 11d. Sorry, 11b. We have to find a plus b plus c plus d. Okay. So if I add these two equations, a plus b plus c plus d is coming out to be 10 times a plus c. Now we have to find a plus c. If we get a plus c, we will get the value of a plus b plus c plus d. Okay. If we subtract these, then a plus b minus c minus d 10c minus 10a. So this is 11c minus c and a. C and a. B minus d is equal to 11c minus 11a. We got the value of we have got the relations in ABCD by subtracting and adding these two equations. See, now a and b are roots of this, c and d are roots of this. So I can get the expression if I put the roots in this equation. If a is the root of this equation, this expression will be 0 by putting the value of a. If I put a in this and c in that, then 10ac 10ac. So in the first equation I am putting the root a, so a square minus 10ac minus 11d is 0. In the second equation I am putting the value of c, c square minus 10ac minus, this will also be equal to 0. Now I will subtract these two equations. A square minus c square minus 11d minus b equal to 0. Now a plus c, a minus c equal to 11 d minus b. D minus b is equal to 11 times a minus c. Now a, b, c, d are distinct, so a minus c get cancelled and a plus c is 121. Put the value of a plus c in that, a plus b plus c plus d is 1210. The correct answer is 1210. This is a very good problem. Once asked in IIT JEE 2006. At that time, there were separate papers in JEE, physics 2 hours, chemistry 2 hours, maths 2 hours. Not like today. Okay, so these were the questions based on the last lecture's study. Now we will move forward For today's lectures theory, we have seen the relation between roots and coefficients of quadratic equation. Today we will see the same relation between roots and coefficients of higher degree equation. Higher degree equations, let's say this is theory of equations. We will see the relation between roots and coefficients of cubic biquadratic. Let's say ax cube plus bx square plus cx plus d equal to 0 has roots alpha, beta, gamma. So from the factor theorem, I can say that this expression is equal to a times x minus alpha, x minus beta, x minus gamma. Okay. If x equal to alpha is root of this equation, then x minus alpha is one of the factor. Similarly, x minus beta is one of the factor, x minus gamma is one of the factor. Now, if I multiply this expression, I get x cube minus alpha plus beta plus gamma, alpha beta plus beta gamma plus gamma alpha x minus alpha beta gamma. Now, right hand side and left hand side, both are equal. We can compare the coefficients. Coefficient of x cube is same. So coefficient of x square, if I compare, I get alpha plus beta plus gamma is minus b by a, which is minus coefficient of x square upon coefficient of x cube. By comparing the coefficient of x, I get alpha beta plus beta gamma plus gamma alpha, which is c by a, coefficient of x upon coefficient of x cube. And by comparing the constant term, alpha beta gamma is minus d by a, minus constant term upon coefficient of x cube. See, we can see the pattern. We can see the pattern of the relation between roots and coefficients in the polynomial equations. Let's start with quadratic. It had two roots. Sum of roots was minus b by a, product of roots was c by a. Now recently we have seen for the cubic equation, if it has roots alpha, beta, gamma, then sum of roots alpha plus beta plus gamma is minus b by a. Then sum of roots taken two at a time, alpha beta plus beta gamma plus gamma alpha is plus c by a. The sign gets changed, plus minus, and all the roots taken, let's say product of roots is minus d by a. So this theory of equations, this theory can be expanded for nth degree polynomial equation. Let's start with a biquadratic equation. If the biquadratic equation has four roots alpha, beta, gamma, delta, then we can write sum of the roots alpha plus beta plus gamma plus delta as minus b by a. Sum of roots taken two at a time, alpha beta, beta gamma, gamma delta, alpha delta, beta delta, gamma delta, done, alpha delta, alpha gamma, beta delta है alpha beta, beta gamma, gamma delta, alpha delta, beta delta, alpha gamma is equal to c by a. Now taken 3 at a time, sum of product of taken 3 at a time, alpha beta gamma delta, alpha beta delta, alpha gamma delta. This will be minus d by a, and product of all the roots alpha beta gamma delta e by a. This can go so on and so on and so on. Sum of roots taken 2 at a time, sum of product of roots taken 2 at a time, sum of product of root taken 3 at a time, and product of all the roots. We can write for n degree equation as well. let's say the equation a n x to the power n has roots x1, x2, x3 and xn. Sum of the roots, summation xi. Yeah, this is summation x1. Summation x1 denotes sum of roots. This will be minus an minus 1 upon a. Summation x1, x2. This is the sum of the product of roots taken 2 at a time. This will be equal to an minus 2 upon a and so on. Lastly, the product of roots. This is the sign of product. This will be equal to minus 1 to the power n a naught upon an. Okay, so this is the relation between roots and coefficients of higher degree. We have seen quadratic, now we have seen cubic, biquadratic and any nth degree equation. The concept is simple. Either take alternate plus minus sign and coefficient of x to the power n minus 1 divided by coefficient of x to the power n. In denominator there will always be the coefficient of leading coefficient. In denominator there will always be the leading coefficient. So we can start with cubic, some basic problems. If two roots of x cube plus 3x square minus 9x plus c equal to 0 are equal, then find the value of c. So what we can do here, the cubic equation is given, two roots are equal, so we can consider the roots as alpha, alpha and beta. And use the concept of sum of roots, product of roots and so on. Let the roots are alpha, alpha and beta. Now I can write sum of the roots is minus 3. Alpha square, alpha beta, alpha beta. Okay. Alpha into alpha plus alpha into beta plus beta into alpha. This is minus 9. Alpha square plus 2 alpha beta. Equation 1, equation 2. And product of roots is minus c. So eventually we have 3 equations and 3 unknowns, alpha, beta and c. Okay. So how we can solve this? Solve 1 and 2 for alpha and beta. In equation 2 I can put the value of beta as minus 3 minus 2 alpha. So the equation becomes a quadratic. Minus 4 alpha square plus alpha square minus 3 alpha square minus 6 alpha plus 9, that is alpha square plus 2 alpha minus 3. So two values of alpha, alpha minus 1, alpha 1. If alpha is equal to minus 3, then beta is 3. If alpha is equal to 1, beta is minus 5. Put these values in this, c is equal to minus alpha square beta. So we have two values of c, minus 27 or 5. There are two values of C. One is there can be two values of C, 5 or minus 27. Okay. So this was quite a simpler problem. Next problem. If alpha, beta, gamma are roots of x cube minus 3x plus 1 equal to 0, then find the value of see this type of question, this type of problem, there is a pattern. Sum of powers of roots of an equation, sum of powers of roots of an equation, here the sum of squares of roots, here sum of cubes of roots, sum of fourth power of root. These problems can be done using the concepts of Newton's theorem, which we catch later. Now in this question we will use the simple identities of three terms: a plus b plus c whole square equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ac, and a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. This problem we will be doing by that identities only. We will study later about Newton theorem, then we will do this problem again using that concept. Okay. So if alpha, beta, gamma are the roots of this cubic equation, first of all what I can write, sum of roots is in this cubic equation the coefficient of x square is 0. So sum of roots is 0. Alpha plus beta plus gamma is minus coefficient of x square, which is 0. Alpha beta plus beta gamma plus gamma alpha is minus 3. Alpha beta gamma is minus 1. Okay, minus b by a, c by a, minus d by a. Now first, alpha square plus beta square plus gamma square. Alpha plus beta plus gamma is 0. Square this expression. Sum of roots, sum of product of roots taken 2 at a time is given as minus 3. So alpha square plus beta square plus gamma square is 6. Now for the sum of cubes of roots, alpha cube plus beta cube plus gamma cube minus 3 alpha beta. A cube plus b cube plus c cube minus 3 abc is a plus b plus c into alpha square plus beta square plus gamma square minus alpha beta minus beta gamma minus gamma. As alpha plus beta plus gamma is 0, alpha cube plus beta cube plus gamma cube is equal to 3 alpha beta gamma, which is product of roots is minus 1. So this is minus 3. Done. Now for the third part, alpha power 4 plus beta power 4 plus gamma power 4. In the first question, in the first part, we have found alpha square plus beta square plus gamma square is equal to 6. Square this, a square plus b square plus c square plus 2ab 2bc 2ca is equal to 36. Now for this expression, consider this as equation 1. Alpha beta plus beta gamma plus gamma alpha is -3. If I square this, plus 2 times is equal to 9. So this expression becomes alpha plus beta plus gamma. This is given as 0. So alpha beta square plus beta gamma square plus gamma alpha square is equal to 9. Put this is in equation 1. Alpha power 4 plus beta power 4 plus gamma power 4 is equal to 18. So we have done this problem using the identities of sum of square of sum of 3 numbers, sum of cubes of 3 numbers, etc. Let's move forward to another problem. Let alpha, beta, gamma, delta are the roots of then the roots of the equation x minus alpha, x minus beta, x minus gamma, x minus delta plus e equal to 0 are, and we are given 4 options. Okay. See, this is a biquadratic equation. Biquadratic equation, we are given 4 roots as alpha, beta, gamma, delta, and we have to find the roots of this equation x minus alpha, x minus beta, x minus gamma, x minus delta. So you must have got that what we will use in this equation. I have told you that roots, if roots are given, then the equation can be written as the using the factors alpha, beta, gamma, delta are the roots of this equation x minus a, x minus b, x minus c, x minus d minus e equal to 0. This equation has roots alpha, beta, gamma and delta. So this whole expression can be written as this should be equal to, hence alpha, beta, gamma, delta are the roots, then I can write this expression as x minus alpha, x minus beta, x minus gamma, x minus delta. In the next line you will get the answer. How? Leading coefficient 1, so coefficient of x to the power 4 is 1. Now substitute e, x minus a, x minus b, x minus c, x minus d is equal to x minus alpha, x minus beta, x minus gamma, x minus delta plus e. We have to find the roots of this equation. So roots of this equation is written as this. The roots of this equation are a, b, c and d. This equal to 0. So we will this equal to 0, x equal to a, b, c and d. The correct answer will be option C. Roots of this given equation, the required equation are a, b, c and d. Is it clear? Let's move forward to another biquadratic equation. If alpha, beta, gamma, delta are the roots of the equation where P, Q, R are real numbers, then find minimum value of alpha square plus beta square plus gamma square plus delta square. So we have to find the expression sum of squares. See, alpha plus beta plus gamma plus delta whole square will be equal to the sum of the squares plus 2 times sum of product 2 at a time. Okay, this you must know. Sum of roots from the given biquadratic equation is minus of minus p, that is p square. The sum of squares of roots, we have to find the minimum value of this expression only, and the sum of product of roots taken 2 at a time will be p. So alpha square plus beta square plus gamma square plus delta square is coming out to be p square minus 2p. Now p is given as real number, so the minimum value of this expression, we can use the perfect square method. I can write this expression as p minus 1 whole square minus 1. So the minimum value will be p minus 1 whole square. The perfect square cannot be negative. It is always non-negative. Its minimum value is 0 at p equal to 1. When this expression is minimum, so the minimum value when p is equal to 1, this expression is minimum. So minimum value of alpha square plus beta square plus gamma square plus delta square is equal to minus. The minimum value of sum of squares of the roots is minus 1. Okay. So in this case the roots must be non-real. That's why the sum of squares is coming out to be negative. So we have seen some questions on the concept of theory of equation, that is the relation between roots and coefficients of higher degree equations like cubic and biquadratic. Now the next topic is finding the equation when roots are given. This we have done. If roots are given of quadratic, biquadratic, cubic. See, if roots alpha beta of a quadratic equation are given, the equation is x square minus sum of the roots into x plus product of roots, where S1 is sum, S2 is product. This we can apply in cubic also. If roots alpha, beta, gamma are given of a cubic equation, then cubic equation is x cube minus s1 x square plus s2x minus s3 equal to 0, where s1 is sum of roots, s2 is sum of product of roots taken 2 at a time, and s3 is product of roots. This we have seen. So either we can use this concept by this concepts for finding the equation having given roots, or we can use another concept, that is our next topic, transformation of roots. Transformation of roots using the symmetric nature of the roots. Using the symmetric nature, when the roots given are the symmetric functions, then we can use this concept, transformation of roots. We will take an example. If alpha, beta are roots of, we will take the example of a quadratic equation, ax square plus bx plus c equal to 0, then find the equation whose roots are, let's say, alpha plus 2 and beta plus 2. We will solve this example by two methods. One by this, by taking sum and product, and another by using transformation of roots. Transformation of roots we will use more often. Okay, so first method is the conventional method. If alpha and beta are the roots of this, the sum of roots is minus b by a, product of roots is c by a. Okay. Now we have to find the equation whose roots are alpha plus 2 and beta plus 2. S1, sum of roots will be minus b by a plus 4, and S2, product of roots, so this is c by a minus b by a, 4a minus 2b plus c by a. Now the equation will be x square minus s1x plus s2 is equal to 0. So x square plus b minus 4a upon a x plus 4a minus 2b plus c upon a. Finally, the equation is ax square plus b minus 4ax plus 4a minus 2b plus c equal to 0. So this is a lengthier method. We have to find sum S1, S2, sum product. Just think that if we have to find the cubic equation, then we will have to find three expression: S1, sum of roots; S2, alpha, beta, beta, gamma, gamma, alpha, and product of roots. So this will be more lengthier. So now we will use transformation of roots. So the question is, this equation has root alpha beta, and we have to find the equation having roots alpha plus 2 and beta plus 2. In this method, what I will say, let y is the new root. So y is equal to either alpha plus 2 or beta plus 2. Either we can take y is equal to alpha plus 2 or y is equal to beta plus 2, and we will find an equation whose root is y. Now from this, alpha is y minus 2. Now we are given that alpha is the root of this equation. Alpha will satisfy this equation. So what I will do, I will substitute alpha, and the value of alpha is y minus 2 from this we have found a quadratic equation in Y coefficient of Y is B minus 4a, constant is 4a minus 2b plus c. This is the equation whose root is Y and Y is equal to either alpha plus 2 or beta plus 2. So if I want to write the equation in variable x, I can say that this equation in x has roots alpha plus 2 and beta plus 2. So this will come out directly. What we had found by taking S1, S2, I have simply find this equation by substituting x as x is equal to x minus 2. If I want to find the equation whose roots are alpha plus 2 and beta plus 2, just substitute x as x minus 2 in the equation, x minus 2. If we have to find the equation whose roots are alpha minus 1, beta minus 1, what we will substitute? We will substitute x plus 1 in terms of, in place of x. Replace x by x plus 1 and you will get the roots as alpha minus 1, beta minus 1. We can take some more example. Ax square plus bx plus c equal to 0 has roots alpha beta. Then find the equation whose roots are 2 alpha 2 beta. So if I have to find the roots, if I have to find the equation whose roots are 2 alpha and 2 beta, then let x is equal to 2 alpha, alpha is equal to x by 2. So what I will substitute? Alpha is the root of this equation, so I will replace x by 2. So this is the equation whose roots are 2 alpha and 2 beta. Second part, find the equation whose roots are minus alpha minus beta. So for minus alpha and minus beta, I will substitute alpha as minus x. So ax square minus bx plus c. This equation has roots minus alpha and minus beta. Okay. Let's expand this question. Second part. Third part is whose roots are alpha square beta square. Fourth part is whose roots are a alpha plus b 1 upon a alpha plus b 1 upon a beta plus b, whose roots are alpha by beta and beta by alpha. So for this we will substitute root x in place of x, ax plus b root x plus c, square the terms. So this is the equation, a square x plus 2ac minus b square x plus c square is equal to 0. For this a alpha plus b, now this is a non-pleasing term, and we have covered it earlier in the previous lecture that you can write a alpha plus b as minus c by alpha and a beta plus b as minus c by beta. So you have to find the equation whose roots are minus alpha by c and minus beta by c. So I will substitute alpha as minus cx. So this is the equation whose roots are 1 upon a alpha plus b and 1 upon a beta plus b. Now in this next part the roots are not symmetric function, they are symmetric function, but what I will assume, let x equal to alpha upon beta, I am not able to get alpha in terms of x or beta in terms of x. So I can use the sum and product, alpha beta is c by a, so beta is c by a alpha, beta is c by a alpha, so alpha square is equal to cx by a. Now substitute root cx by a in place of x. Simplify this and you will get the equation whose roots are alpha by beta and beta by alpha. Okay, so we will do these type of problems for cubic also, and then in these type of problem we will see the Newton's theorem, which I had discussed earlier, which I had taken the name but did not discuss it. We will discuss in the next lecture. Let's conclude this lecture at this point, and we will continue from this transformation of roots by taking examples of cubic, can take biquadratic, and then we will explain the Newton's theorem for finding the sum of higher powers of roots, like the equation has roots alpha and beta and gamma for a cubic equation, and we will find a relation between alpha square plus beta square plus gamma square, alpha cube plus beta cube plus gamma cube, alpha power 4 plus beta power 4 plus gamma power 4, sum of powers of the roots of equation. The relation in them is called obtained by Newton's theorem. We will see that in the next lecture. Okay, bye bye, take care.